Now we are going to I'm going to introduce a new topic, that is strength and load. So what are the strength and what is the load? Strength is being represented in the form of S, and a load is being represented in the form of L. And what are these S and L? S represents the allowable permissible load. Okay, so S is basically the allowable or the permissible load. And what is load? Load, L is represented in the represented as the induced what is this? Oh, this is induced. This induced, induced or applied stress. So load is basically the induced or applied stress, and strength is basically the allowable or permissible load. So the strength and load, and these strength and loads are represented in the form of PDF. So when we represent this PDF, this strength and load in the form of PDF, what we wrote, we have a function in the form of like this. We have Fs of S and FL of L. So we have Fs of S for this is the PDF of strength, and FL of L is the PDF for load. Okay. Now we have to find out the reliability when we are given two things, strength and load. So the reliability when we are given these two terms, these two things, what would be the reliability for the strength and load? So reliability is basically the probability of anything. So the probability of strength and load. First, what we assume that we have a probability for strength greater than load. We have a probability of strength greater than load. So when we say we have a probability of strength greater than load, so this means that we have S minus L, strength minus load is greater than 0. So, and what would be the end equation? So the reliability is being represented for the strength and load. The reliability for strength and load would be the probability of strength and load and the joint PDF of strength and load times ds and dl, derivative of S, derivative with respect to S and derivative with respect to L. So this is the joint PDF for the strength and load, and this is the reliability of our function, of our variables, random variables. And this S and L are basically independent random variables. They are independent random variables. Okay. And first we say that we have a limit of L, that is L minus dl over 2 and L plus dl over 2. So this is basically our area. We have an area of L, that is from L minus dl over 2 and L plus dl over 2. We have this area, so we represent it as AL, and we say that the area for AL is in the form of, we have a limit from this to this, so we say this limit as FL of L and dl. So we have an area, and we say that we have a probability of that area L, which has a limit of from going from L minus dl over 2 and L plus dl over 2. So we represent this thing in the form of FL of L and dl, and this is our area. We have A is the area. Got it? Now when we say that when we have a probability of S greater than L, when we say we have a probability of S greater than L, so how can our reliability can be written? We wrote the limit of S from L going from infinity. Why we did so? Because we are saying we have S is greater than L, so S can be anything from L to infinity, greater than L. So the starting limit would be L, and the ending limit we don't know, so we put it as infinity. So the limit for S is L to infinity, Fs of S and ds. And we have another, you remember, we are replacing this R here, this R function, this R formula, in the form of our limits that are being provided to us. and the area that we are talking about. And the other limit is for L. We don't know the limit for L. L limit is not defined here. We only got the limit for S, that is that is greater than L, but we don't know the limit for L. So that's why we put the limit minus infinity to plus infinity. F L of L and dl, rest remains as it is. So this is the overall reliability for when we have a probability that is S greater than L, and we say that we have this this reliability, we have this thing, this limit, that is L going from that is limit going from L to infinity. We have this limit of fs of s of ds. Okay, so we wrote it as 1 minus fs of s. This thing can be written also in the form of this. We just say that this whole term, why we have done this thing, because we remove the limits. We remove, oh sorry, not the limits, we remove this integration part in this derivation here. We remove this integration, so the method, the way of writing when we removed our integration is something like this. We removed it, so this equation becomes 1 minus fs of s. Got it? Now we have this this reliability can also be represented in the form of like this. See, we have we have L, that is minus infinity to plus infinity, f L of L, and in the place of this we wrote 1 minus f s of s and dl. This dl comes here. Now we say we have second part, that is the probability L is less than s. So we have changed nothing, we just have changed our possibilities. First we say that s is greater than L. Now we are talking about L that is less than s. So just we have changed our positions, and by changing our positions we have defined basically the reliability. In first part we defined our reliability for s. Oh sorry, not reliability, we defined our limit for s, and now we are defining our limit for L. So what happens now? It's the same thing. Is S is also the basically the area, that is from s minus ds over 2 to s plus ds over 2, and it is represented, area is represented in the form of as, and it can also be written in the form of fs of s in ds. Okay, and now we have defined our limit of L. What we have defined our limit of L, that is less than s. We are talking about less than s. So less than s can be any number from minus infinity to s, right? You got the limit. How we are defining it? It is the minus infinity to s, f L of s. Why we wrote here f L of s? Because we are defining our limit of L in the way of s, in the form of s. We are defining it that it is from minus infinity to s. So that's why we have write it f L of s here, and we are going to do derivative. We are here we are going to integrate it in the form of s with the function f of s. So that's why we have written it like this, because we are defining our limit from in minus infinity to s. So that's why we have changed our integration. With respect to integration, we have changed it in the form of s. And what this, when we remove our integration, so this thing can also be written in the form of like this. Okay, got it? So by removing our integration, this is also written in the form of like this. And what happens now? We got the reliability as f L of s, and the other term, that is, here we have put fs of s as minus infinity to plus infinity. Why we have created this? Because it is the same, you remember, like we put the limit of f L of L dl s from minus infinity to plus infinity, because the limit for L was unknown. So that's why here also we don't know the limit for s. So that's why we have created from minus infinity to plus infinity. So what we got, the final reliability is R equals to FL of S dot minus infinity to plus infinity Fs of S and ds. This is our final reliability. Now what we are talking about? We are talking about the probability of failure. That what is the probability of failure? The probability of failure is when we don't have a good reliability. Our system is not reliable. When we say our system is not reliable, so we'll put it as 1 minus R equals to F. F is the probability of failure. F is the failure basically. So when we suppose this, now we are working on our failure of the system. First we say the reliability of the system. Now we are talking about the failure of the system. Now what happens? P is the probability here is S is less than equal to L. Now we have put another probability, that is we have taken another probability, that is S less than equal to L. The strength is less than equal to L, the load. And what happens when we say this? There is nothing different in this, just we are taking our this equation. You see, we are taking over this equation, minus infinity plus infinity Fs of S, Fl of S and ds. We are just taking over this equation and we are putting, because you know this is the final R that we got. So here we are talking about probability of failure and the function that is not reliable, so that's why only this one minus is being added here. That's all, and nothing so complicated or so, you know, not a different thing, not different anything, nothing different is being happening. It's just the simple scenarios and all. So what we have PF, probability of failure. We have PF equals to minus infinity to plus infinity Fs of S ds. Okay, and this Fs of S multiplies by this also. Okay, this Fs of S multiplies by this and this multiplies by this, and this minus remains here. So this is basically multiplication is happening. So this Fs of S multiplies by this 1 by 1, so we got here this, and minus comes here, and this thing, whole thing multiplies by 1, so whole thing comes here. So this 1 is being multiplied by this first, and this 1 is being multiplied by these both terms. So we got this here, and we have a minus in between. This minus comes here, and what happens? We can see that we have a common. What we have common here? We have minus infinity to plus infinity, limit of minus infinity to plus infinity Fs of S ds. These are the things that are common. So we will bring them out. When we bring this minus infinity to plus infinity Fs of S ds, we bring it out. What remains here? 1 remains here, minus. In the place of this, we only have left Fl of S. So this only Fl of S is being remained here. So this comes here and this thing comes outside in the form of common. So this is our probability of failure, the final probability of failure, the final function for our probability of failure. So that's all. That was all for the probability of strength and load. When we are talking about the reliability of strength and load, and we also talked about the probability of failure when we have a failure in our system. So that was just 1 minus R equals to F, and we got the probability of failure, and we got the reliabilities of our strength and load. And now we are going to do a numerical. This is basically a numerical. What this numerical is? This numerical is quite different thing. This is something different. This numerical is something different. We have SY is 30 lb over inch square. SQ, we have a formula of SQ, that is P into D over 2T. And what are these terms? Now we are going to say what are these terms. So SY is basically the maximum strength. So this is what this numerical is based on. Why we are doing this numerical? We have to find our strength and load balancing. Okay, so we have to find our strength and load. So that's why we have to find our probability So that's why we are having our numerical, we are doing our numerical. So we have to find our probability of strength and load. So how we can find it? We have a data that is given. Sy is basically 30,000 lb over inches square. Sy is maximum strength, and we have Sq, that is P into D over 2D. And what is this Sq? Sq is the average strength. Sy was the maximum strength, Sq is the average strength. And what is this P? P is basically the pressure, D is the diameter, and this T is the thickness. Okay, so what this numerical is based on, we are finding our probability for strength and load when we have given a maximum strength and average strength. Okay, this average strength, we have to find out this average strength when we have given the maximum strength and our load strength. So maximum strength is basically 30,000 lb over inches square, and we have to find the average strength, and we have given the load strength. Okay, P is our pressure, D is our diameter. What is the way of finding our average strength? We can find it in the form of this: P into D over 2T, where P is the pressure, D is the diameter, and T is the thickness. Okay, and let's move on. See, we have T is the thickness. Now SQ was average strength. SQ can be easily find. We have given P pressure, that is 400 into 72. 72 is the D diameter. Remember, the formula is P into D over 2T. So P is the pressure, that is 400, D is the diameter, that is 72, 2 into T, that is T is the thickness. So T is 0.5. So we got average strength, that is 28,800 lb over inches square. Now I told you that L this is our load strength. Okay, so we have put this thing here so that this and our maximum strength don't get mixed. Okay, they didn't get mixed, so that's why we have put this here, and we have put this here. This is our load strength and this is our average strength, and Sy was our maximum strength. Okay, now what we have the formula? We have the formula for finding our probability, that is P equals to Sy over S plus L. Sy is the maximum strength, S is the, this S is this is the average strength, and this L is the load strength. Okay, so it is given here. Now we are just going to put the values in the place of Sy. We have, remember, we have Sy is 30,000 lb over inches square, so 30,000, and in the place of S, in the place of average strength, we find 28,800 plus 30,000. 30,000 is our load strength. We have given the load strength as also 30,000, so that's why we have kept load strength as 30,000. And when we do the multiplication, we do addition, and then we divide both terms, we got probability as 0.5. so probability is 0.5. so we have S over L balanced. This is the way of balancing S over L. We find the probability for this. Okay, for strength and load. So that was all for now. That's all for the strength and load topic.